Hello and welcome to SpaceTime. It's a long cosmic voyage looking for answers. Have you ever wondered what the universe is made of? Everything stars, planets, you, me, and even our coffee mug is made of matter. Matter is just the stuff that has mass and takes up space. Imagine a universe where every particle has a twin, but with opposite charge. That is antimatter, the mirror image of matter. Antimatter is strange, invisible, and incredibly powerful. If matter is the hero, antimatter is its mirror twin and its sworn enemy. Every particle, electron, proton, neutron, has an opposite version called an antiparticle. They are identical in mass but have opposite charges. For example, the electron's antimatter twin is the positron, which carries a positive charge instead of a negative one. And here's where things get wild. When matter and antimatter meet, they annihilate in a brilliant flash of pure energy. It's like meeting your evil twin. The moment you shake hands, both vanish in a burst of light. When the universe began, physics says it shouldn't have had just matter. It should have had equal amounts of matter, antimatter. Yet, despite the Big Bang's equal creation of both, our universe is overwhelmingly matter-dominated. Why is there such an imbalance? This question has puzzled scientists for decades. If matter and antimatter were created equally, where did all the antimatter go? The absence of antimatter is one of the universe's greatest enigmas. Could it be hiding in distant galaxies or lost in the vastness of space? The quest to find it continues, driven by curiosity and the promise of discovery. If there was equal matter and antimatter in the beginning, shouldn't they have completely wiped out each other? Shouldn't the universe be nothing but light? We couldn't exist in that kind of universe. Yet, here we are. Clearly, matter won. But how? Scientists think that in the very first moments after the Big Bang, there was a tiny imbalance. For every 1 billion antimatter particles, there were 1 billion and 1 matter particles. When the rest collided and annihilated each other, the tiny surplus, just 1 particle in a billion, survived. Those leftovers became everything, every galaxy, every star, every human being. But why did that imbalance happen? We don't know. Maybe matter and antimatter follow slightly different rules of physics. Maybe unknown forces tipped the balance. Or maybe the antimatter isn't gone at all. Perhaps entire antimatter galaxies still exist far away. And if they ever meet us, boom. In 1928, physicist Paul Dirac predicted antimatter with mind-bending equations. 4 years later, Carl Anderson discovered the first antimatter particle, the positron, hiding in cosmic rays. Antimatter isn't just in labs or science fiction. It appears naturally. In cosmic rays hitting Earth's atmosphere, in certain radioactive decays, near extreme places like black holes and neutron stars. We can even create it on Earth, in massive particle accelerators like CERN's Large Hadron Collider, but only in vanishingly small amounts. And storing it is tricky. Touch normal matter and it's gone. The energy locked inside antimatter is mind-blowing. Just 1 gram of antimatter meeting 1 gram of matter would release as much energy as a nuclear bomb. That's because when they collide, their entire mass turns into pure energy, the ultimate power source. That's why scientists dream of antimatter-powered spacecraft. A rocket fueled by antimatter would reach Mars in weeks, or even travel to other stars. But the problem? Producing even a tiny amount of antimatter costs billions and takes years, and storing it without touching anything is an enormous challenge. But antimatter is already helping us today. In PET scans, positron emission tomography, a small amount of radioactive material emits positrons. When these meet electrons in our body, they annihilate, releasing gamma rays, creating detailed medical images that help doctors save lives. Here's the mind bender. Everything, the Earth, the Sun, the Milky Way, exists because in the universe's first fraction of a second, there was one extra matter particle for every billion antimatter particle. If that imbalance hadn't happened, no stars, no planets, no life, no you. It's one of the biggest unsolved mysteries in physics. We don't know why the universe chose matter over antimatter, but that tiny, almost impossible difference is the reason you are here listening to the story right now. Makes you wonder, if the universe rolled the dice again, would we even exist? And somewhere out there, could an entire antimatter universe be asking the same question about us? Antimatter reminds us that the universe is stranger, more complex, and more beautiful than we ever imagined. And maybe, just maybe, solving its mystery will tell us why there is something instead of nothing. The cosmos has endless secrets, so stay curious and keep exploring with me. This is Saranya, and this is our SpaceTime.